Hey, this is Steven from Legit Tech Tutorials and the Green Engineers, and welcome back to the DIY metal milling machine. So this is known as the Green Machine, and this is episode 13. Should be DIY metal machine 13. Yep, 13. So that means almost 2 weeks straight that we've been working on this guy. So everything here looks good. So let's look at the layout that we have going on right now. So I am pretty happy with this. Oops. I am pretty happy with this layout. Did I just touch my DPI? It should be okay. I thought I hit my DPI button. Still need to contact these guys about getting the 3D model for this guy, so I could better represent it. But overall, we are looking pretty good. Again, we're at about 400 pounds. That's a weird artifact. And everything is fitting together rather nicely. Obviously, some of the stuff needs to be opened up, but that is okay. So another thing is that obviously up here, we're going to have a motor mount that goes up here that allows us to stick our motor there and have a coupling to have the and it'll probably be raised a little bit up, and then so it'll be like bolted down, and then we'll have our coupling here going inside of this block probably to protect, and it's going to be probably a flex coupling just so that we have the and then it will block all the chips from getting up in there because it's inside the coupling. Same deal here and here. Obviously here it's going to be sticking out. Well, what I want to do on this one is I want to have it because I have less clearance here and I don't want anybody to bump into it. I'm probably going to put some feet on the bottom, and the motor will actually be down here, and then it will be pulleyed. I'm thinking something similar here, but I don't really have the room. So what I'm thinking, I might even put the motor over here on this side and then have it go here, because this is going to press against the back wall here, and I want it to kind of be pulleyed. Same deal with this one, but obviously here I do not have the clearance, because originally I was going to have the motor sitting down here and have it go underneath, but then I'm going to lose a lot of clearance, and the higher up this guy is, the more of a moment we're going to get for this rotation here. So might put the motor back over here somewhere. And again, this is how tall? This is 2.5 inches tall. So let's see here. So let's look at NEMA 20. We could probably do a NEMA 23. And eventually I want to go with some sort of maybe like a $25. Yeah, that's a little big. And also I'm looking at possibly purchasing G-Wizard. I'm pretty sure I hit the DPI. Anyways, 2.25, so that'll just fit on the side here and not worry about any sort of clearance. But obviously what that means is that we're gonna hit here. So maybe one of the things that we could do, so how are we gonna do that? So obviously you can't fit down here because it's gonna hit, and it's going to hit over here, and we're going to lose here. Put it on top But then this top piece is going to have to be 2.5 inches tall. But one of the things is we can put it up here on the front. It's going to stick out an additional 2.3 inches, which is not very far. And we're not going to have any issues with clearance. And it's not going to hit here because it's on this side, or this side, whichever. We don't have to worry about the clearance. And the front is really what I'm not too worried about. And then same deal here, put it here. Put the motor down here. And then we should get the best of that. I mean, there's not really any other place. I mean, obviously that's extremely strange to put it there. You know, and then we'll have to put something on top of it. But other than that, I think that'll work. Okay, so now, again with the math. Oh, and then I remember our math was wrong here before. So let's go ahead and fix that. So... yeah, and we could see them in there. Oh, and then I have my little notebook. That's why I wrote down the notebook. So this is negative 22.75. You see the little nub there. Obviously, there's going to be another nub there. So if you want to do this, you move it all the way back, and then you could get the thing underneath it there. And then these are stationary, so they're always going to be going back and forth with this. Oh, is that almost flush? Oh no, it's sticking. Sticking over just barely. So we're losing a little bit there, but we could probably get this guy to come off even a little bit more to where this is flush. So we could probably come even more. But anyways, so let's go the other way. Drive joint. So let's say that this is... oh no, positive 1. Why did I write negative 2 there? Plus 1. Okay, so now basically, again, let's open up the Trello here. So now if we go from here to here, we're talking 23.896. Wait, where did I do that from? I just have to stay consistent on where I do it off of. Oops. .24 inches. So this is 23. So total is 32.896 plus 23.854. That's 56 inches. Total that we have is supposed to be 48. So let's cut off 8.75 inches. Oops. So basically what it looks like is that we're getting rid of the center portion. So now it's going to stick out quite a bit, and we're losing 9 inches there. Okay, so custom X gantry, bodies, oops. Okay, so the new one is +1. Let's say like -11. Okay. So say new one's -14.15. So that's 15.15 inches, right, for travel total. Okay, so now let's see if we could clear that. This distance is 24 inches. Now, 24.25. And that's at that distance. And let's drive it to +1. And this is 15. Looks like we are short. 146 plus 24.25. So we are short approximately 48 inches. We're short approximately 9 inches now. 9 inches of movement. So what I'm thinking is that it's double, because remember we took off 9 and we actually lost 9. So now if we add 4.5 back, then we should get what we need. And then this divided by 2 equals 4.3. So now if we go back and we change this to add 4.3, because we're moving it twice, plus 4.3 something. $4.302. Okay, so now let's go ahead and save this. Let's go ahead and update this. So now we should actually get almost exactly what Tormach's got. So now we're going to keep the same 1, and we're going to delete this again. And let's go ahead and drive the slider, and then let's go negative. The last one was -14. Let's say like -16, -18. -19, 18.5. That's okay. Probably 18.45. 18.45, -18.45. Okay, so -18.45 to 1, so now we have 19.45. It's almost exactly like the Tormach. Okay, so now let's look here. Basically what I'm going to do is go from here to here. It's 28.554. Let's drive the joint, and let's go to +1. That's 19.448. now I can tell you we are really close. 28.554 plus 19.448. It's 48 and 2 thou. Alright, so that is a total of 19.45 inches. 19.5 inches. That's another inch and a half over what the Tormach requires. And let's go ahead and see. Let's see the total travel of the head here, of this other axis here. So let's go here and pick one of the joints. Drive joint. Let's see. Let's pretend that this is on the inside. Oops. 0.75. I mean, this is obviously to a big extent here. Okay, so now let's say here, so the y-axis is about from 0.6 to and of course we could go over the table but we don't want this to go past, which it looks like it's pretty much there. It's 0.6, negative 15.75. So total is 7.3, so it's about 16.35 inches. So 16.35 inches on the, so let's look at total travel. And obviously we're losing some here because they're basically two combined. So this should be 28 inches, right? This should be 29 inches. This should be 29 inches from here to here. Oh, it's 28. So this is actually supposed to be longer. But we have the pulley there for clearance for the pulley, so I mean 28, 29, whatever. 1 inch, we could probably add another ½ inch and have a pulley stick out ½ inch or whatever, but that sticks here and we save with the motor. But anyways, total travel is X is 19.45, 19.45, and Y is 16.35. Now that's the total travel, but in this case our bed is only 9 inches, right? It should be 14 inches. So what that means is that we're going to lose a lot of travel, right? So here the travel's not balanced. So let's see here, custom X gantry. So this is actually supposed to be larger. Let's see if this breaks everything, which it does. I mean, that's basically it. Obviously, we'd have these separated, but you get the idea. Let's see if it breaks everything. Nope. Okay, so let's go back here. I mean, obviously, this is incorrect, so slider here, drive joint. So this is going to be super stable. Because that means that our part can only be 9 inches, which is not quite what we would like it to be. Because we want our table to be just as big as what we could load onto it. We don't want it any bigger, we don't want it any smaller. Okay, so let's say that. So now we're at 13.40, because 16 was way too much. I should have known that that was, because that's almost square. That's not right. And then obviously, so this is going to be so stable. But here's the issue. I have to make something that big. I'll see that that's good. So to minus 1.90. So basically it is 13.40 minus 1.90. So it's about 11.5, which it should be. Oh, and we're losing some here. Right, we're losing this distance here, so that's 2.5 inches. So it should be, well then again, this thing's only 28 inches, so we're losing 28 divided by 2 is 14 minus 2.5, which is yeah, 11.5 inches. Well, it's actually 12.5, losing 1 inch somewhere. Anyways, yeah, but that's still 2 inches bigger than a Tormach 1100, so that's good. But now we're gonna bump up this weight quite a bit. So now we're almost at 11,000 ounces. Oops. We're at almost 600 pounds now at this point. Oh, and then also, this is bigger than 9 inches, so it's not going to fit inside the vise. So basically, we're going to have to stick it in the bottom. And then, obviously, these we're going to have to send somewhere to be surface ground flat, which hopefully doesn't take that long. I mean, this one does. These ones don't. I mean, this doesn't matter. That doesn't. This is machined. That doesn't matter. That doesn't matter. This kind of matters. This kind of matters. That kind of matters. I mean, these are basically going to be machined straight on the machine. This guy. Because, yeah, these have to be in line, because otherwise stuff's going to be tweaked out. Anyways, but yeah, you can put this in the vise upside down. So machine half of it, and then flip it over, machine the other half. Anyway, so this we might have to machine on a different machine instead of the jet. So we might have to think about this, because this is a big boy. So maybe my boss has something that'll open up 14 inches. Obviously, it's a vise, so you can't do the inside. Maybe we could do a fixture plate where maybe we glue it down or do something, some sort of industrial tape, and we square it up, and this also doesn't matter. It's just these machine parts, and then now this is going to have to be machined. Oh, but it doesn't. We're just going to machine it on the machine. It's just going to come in, and we're going to machine this with a big shell mill so that it reaches all the way to the edge, and then we're going to machine this, and then use a what's it called, not a file. You know what I'm talking about. Not a grinding block. It's like a grinding stone. Just stone it. Hit it with stone, knock over all the edges, and boom, there you go. Then we could put some holes in it with the machine, and we could do some, put a fixture plate on top. So this is going to be decked with respect to the machine so that everything is square with respect to the machine at all locations. Alright, so now that we have that, and obviously I'm going to need to go get some shorter ones, but we've seen that all on footage, so we don't need to see it again. But we're going to just drop this size. Is that now basically what we need to do is we need to stilt this out, that distance here, which is about 28 minus 28 and a half. 28 divided by 2, which is 14, minus 2.5 is 12 and a half inches. Or in this case, the middle of the travel, which is 11.5. Yeah, I mean, is it basically 11.5? No, it's got to stick out half of that. So what's 11.5? That's about 5.75 inches. So if we go up here and we click this, let's go ahead and capture a component. And let's see if we can. Oops, that's the seal. We want this. This is the mounting block. Okay. See how it's nice and flush there? So, yeah, let's not do that. Okay, so now basically this guy's got to stick out 5 3/4 inches. 5.75. And so how much additional do we have to stick it out? I think we'll have just enough room for the motor. This is already 2. So that's the center, obviously. So it has to stick out to the center. So we need 5.75 minus 2 point whatever. So we have 5.75 minus 2.382 is 5.75 minus 2.382 equals 3.368. So we need even more than this, but then again, this thing is 4.75. So I mean, if it was that whole thing, it would be really close. Plus the bracket thickness. So let's say the bracket was like 3/8 thick. So then that's only 40 something thousandths. 3.40. It'd probably be that 68 thick just to shim it. And then we have the motor that fits in there, which has to be about 3 inches. Where's my calipers? So the motor is going to have to be about 3 inches. That's a big motor. That motor is about almost as big as this guy. And then obviously a motor sticking up and clamps onto this guy. So what if we bought one of these spindles? Oops. I had that guy talk to me. Let me see. Oh, he said 65. It was a 65 millimeter. Ooh, so that's 2.6. And that was a 2 horsepower. Do we have a bigger one? That's the other thing. It needs to be, obviously, that piece needs to be shorter than this, with all the way down to the electrical, because we don't want to, cut anything or ram it into anything. So let's look at the power head. Oh man, so beautiful. Look at these. $79. Oh man. I mean, it's probably not balanced to super high RPM, but we only have 6,000 RPM to work with anyways. So, or it could even be kind of like Garbo ones, like these ones. I mean, they're not garbage, but they're not the best quality. But I like how far they stick out. They don't stick out very far. Okay, so yeah, so we just get one without a pull bar on it. Okay, so just have a ER16, ER32. That's 0.006 run out, which is really, really small. I'm assuming that's what it is. Yeah, body accuracy, 0.006 millimeter run out. Alright, so, yeah, let's finish this up because we're probably over time. Yep. Okay, so we were looking here, and this whole thing is 361 millimeters long. So now let's see what that one, I think that was a 1 horsepower, or 2 horsepower, or 1.5. Okay, so here is this one, 240. So 240 versus 361. That's to the spindle. So that's another, what did I say, 240? So that's another 120 millimeters. And it's about 5 inches. That's a lot of clearance. And 65 millimeters. So if we did decide to do that, we are looking really, really good. And then this would be a high quality thing to use with a BT40 collet. So, and obviously the run out on that is not a big issue, and the bearings on that spindle will last a really, really long time. And also it will keep these, because it has low run out and it's low load, it'll keep these running a really, really long time. So these up here, these shafts here, compared to down here, so I think that's really a good option. Or we could use that brushed spindle that's in some sort of old Craftsman lawnmower. Yeah, so this looks really, really good. I am excited. So that spindle, where'd it go? With that spindle, I'll probably add another. Oh, and this is just. Oh, this is a 1 horsepower though. Let's see if they have a 3 horsepower. The ATC spindle, $1,700. 3 horsepower, $200, and then we need a VFD, which looks like another $105 that we need to like put underneath the machine, because we don't really have any other space up over here. Because yeah, so place it underneath the machine. Here's about $320 for the set, or $375. Oh, wow, it's way cheaper to ship it from in the United States. Unless maybe I dropped this. Nope. Nice VFD, 3 horsepower. So that's another option, but you're talking there, so yeah, we're definitely above the $1,000 range. So what about the 4 horsepower? But again, this is probably rated at that much. So let's do this one last check. So this is rated at 3 horsepower, right? There we go, that's better. Well, it's still about the same as the United States. So, and this current ooh, we need 220. I doubt I'll be able to find something 110. Input phase, 1 or 3 phase. Oh, output voltage. I mean, I do have in that garage, but we're at 36 minutes. So I don't know what this accuracy means, but anyways, yeah, so let's see if we have 4 horsepower. Oh, that's just a VFD. 3 kilowatt is about 4 horsepower. So it's about $500. But does it give the dimensions? This is 2400. Length 220 millimeters. So it's still, but it's now 100 millimeters. Which is too big. So maybe 3 horsepower then. Well, alright, well, we're definitely learning a lot of stuff here, so. But I like the length. The length is still under, it's still about a couple. This is the whole thing's 360. So it's still under. Oh, 3 kilowatt, it's 4 horsepower. So it's still under by 140 millimeters, which is 5.6. All right, so things to think about. Anyways, this is the end of episode. Stand by. Episode 13. So this has been, and I do feel myself getting a little sick, but we only have one more day until the series resumes next week on Monday. So thank you guys so much for watching. This has been Steven from Legit Tech Tutorials and the Green Engineers, and I'll see you guys in the next one. Thanks for watching. Take it easy. Peace.